Welcome everyone. Today we are learning something that seems like math, but trust me, it is the foundation of machine learning. That is the Cartesian plan and the distance formula. Stay with me till the end. You will see how machines use these to understand different patterns and how they decide what is similar and what is different. So let's get started. Uh, let's begin with a simple question here. Let me turn on the pen. So, um, you and your friend are standing at two different spots. So, here are you, uh, and here is your friend, right? And you guys are standing at two different spots. How do you say how far apart you are from your friend? You cannot just point out and say, my friend is there, or my friend is, it would be like pointless to say he is there or he is near to me. We need a way to measure the distance between you and your friend. That's what today's lesson is about. We will use coordinates. So, and we will also calculate the distance in this video. So, let me start with a very simple concept, which is partition. I shouldn't say plane because it isn't a plane, it's just a line. So I should say a line 1D. So think about a straight line. This is a straight line, and this is a very simple and basic concept. So like a number line from your school, you are standing at a 0 point. So let's consider this as a 0 point. You are standing here and your friend is at 5. So let's say this is 1, 2, 3, 4, and 5. And your friend is standing here. Okay. So how far apart is your friend from you? Just subtract 5 minus 0, which is equal to 5. So your friend is 5 units away from you. If this scale is, let's say, meters, so you would say that your friend is 5 meters away from you, standing away from you. So that's one dimensional distance. But the real world is not only the one line. So you should say like I am 5 kilometers away from my friend. So the real world is not only one line. We move sideways, we move up and down. So we need two dimensions. This is where the Cartesian plane comes. So look at this. There are two lines crossing each other at 0. So we call this as an origin. The horizontal x-axis is called as x, and vertical line is known as y. So we call it as y-axis. Every position is given by two numbers. So let's say this is a point. An example is this is a point A, and uh, this point is 3 comma 2 in the Cartesian plane. So it is 3 units in the x-axis. So let's say this is 0.5 and 1, 1.5 and 2, 2.5 and 3, right? So this is 3 units in the x-axis and 2 units in the y-axis. So this is 1 and this is 2. So this is 3 in the x-axis and 2 in the y-axis. That means that 3 steps to the right and 2 steps up. And let's say there is another, so this is a point 1, point A, I should say. So we also name these points, and there is another point, we call it as point B. It is minus 4 comma minus 1 are the coordinates. So we call these as the x and y coordinates. So it is we all know that you should know that x and y axis in the quarter 1 is positive. So this is first quarter, this is second, this is third quadrant, and this is fourth quadrant. So in the second, or if you go left to the x-axis, it is x-axis is negative, and if you go down, the y-axis is negative. So if you go here, it will be like minus 4 points in the x-axis, like 4 steps left and 1 step down. So we write it as point B as 4 minus 4 comma minus 1. So we can now describe any location by these two numbers. So let's say if a point is here, we will see that in the x-axis it will be a negative number, and in the y-axis it will be some positive number, and by these two numbers we can define any point in the Cartesian plane, right? So let's move to the next slide, which is machine learning intuition, like why we are reading and understanding these Cartesian plane and why we are starting from here. So now, how does I should say that how does this connect with the machine learning? So let's say, uh, let me draw this graph again. So on the x-axis, just say there are on the x-axis we are tracking the study hours, how many hours any student studies, and on the y-axis I am tracking the exam score. So each student is a single point here. So let's say, let me draw a point here. So if a student is studying 2 hours, so if this is 0 0.5, 1, 1.5 and 2. So if this is 2 hours, if a student is studying 2 hours and scored 30. So let's say this is 5, 10, 15, 20, 25 and 30. So this is the point, the person A, and this will be 2 comma 30, right? So he scored 30. This is 10, 20 and 30. There is another student who studied, let's say 3 hours. So if this is 3 hours and he scored, let's say 50, so this is 40 and this is 50. So he scored 50. This will be the person B, and the coordinates for the person B will be, he is in the x-axis, he is studying 3 hours, which is 3 comma 50. He scored 50, right? So when we plot many students, like let's say if this is another student, this is another student, if someone studies this, and if someone doesn't study, he may be able to even score 5 points in an exam. So we may plot many exams and a certain pattern will start to occur. So uh, let me draw a certain pattern. So if you would see that here is a certain pattern that we have started to see, that shows that if any student studies more, he will be scoring higher in the exam. This is how machine learning begins. So for example, if we ask computer, if a student is gonna study 5 hours, predict how much score he is gonna make in the exam. So what machine learning does is it tries to understand the underlying pattern, and let's say it is here, and if I extend the line, so let me change the color. So if I extend the line here, what machine learning algorithm will do is it will try to find 5 hours, or in the x-axis it will try to find the 5, and in the y-axis it will try to extend this line and see a underlying pattern, and maybe able to predict that it will be, the person will be scoring 70. So if someone is studying 5 hours, he will be scoring 70. So this is the main point about machine learning. So the main goal is here to understand the underlying pattern. Once we have enough data, we'll be able to find underlying patterns, and then machine learning algorithms extend this thing, and finally it predicts accurately, and we will see everything literally how these algorithms work, but this is just a very basic concept about why we are learning Cartesian plane. Moving to the next slide, explaining distance formula. This is the big question. How do we measure distance between 2 points? So there is, let's say, there's the same plane. There is a point that is 3 comma 2, and there is another point which I should say that point B is at -4 comma -4. So if we draw a triangle, there is a famous famous theorem known as Pythagoras theorem, which suggests that this hypotenuse, we all know that this is the hypotenuse. We call it as an, if there is a right angle triangle, meaning if a triangle has 90-degree angle, the opposite side of that 90-degree angle is known as hypotenuse, and these are the other two sides. So if we square and add other two sides, it will be equal to the square of the hypotenuse. So I'll be drawing a right angle triangle here, and connect these two lines, point A and point B. Here you can see we have a we have a right angle triangle. So this angle is 90-degree, and this is the distance that we need to calculate. This is the point A and this is the point B, right? So from the Pythagoras formula theorem, we know that square or d square in this case, the hypotenuse square is equal to side 1 square plus side 2 square. So uh, what we need to do is we need to find the c. So this is the formula to find the distance, and this point is basically uh, what we need to do is, this is x1, let's say this is x1, this is y1, and this is x2, and this is y2. So c will be equal to square root of a square, which means or b square, this is b, and to find the length of b from point, let's say A to point C, what we do need to do is we need to subtract 3 from the -4, or the formula becomes x2 minus x1 whole square plus y2 minus y1 whole square. This is the same as this one, but I just have written it in the coordinates. So x2 is 3 minus, and x1 is -4, and we just need to square, and then there is 2 minus -4, and we need to find the square root of all the sum of these two numbers. So this will be 7 square plus 6 square whole square root, sorry. So this c will be 49 plus 36 and square root of this numbers. This will be the distance between point A and point B. So why distance matters in machine learning, and why we are learning, and why we do care, we do need to care distance in the machine learning. This is because in the machine learning, distance tells us similarity between different categories. So let's say there are different people, and we are just mentioning them on a graph paper, and then there is another group of people that is there is an example like customers by spending habits. So if I have on the x-axis I have annual income, and on the y-axis I have spending score, right? So we can see that the more people have annual income, the more they tend to spend, or they have higher spending score. And there is a third group of people, they have highest annual income and their spending score is very much high. So the distance is very important here. So these are two customers. Let's say this customer, the distance between these two customers and the distance between this customer and this customer is very different. So what we do, or what these companies do, is they create these clusters. So this is different cluster of people, this is a different cluster, and this is a different cluster of people. So machine learning use these distances to group people. That's called as clustering, and we'll be learning different clustering algorithms as well. And there's a recommendation system. For example, if a company wants to promote certain products, they may only be able to, or they may only choose to promote these products to people who have highest annual income. So that's how machine learning is used, and distance is used in the machine learning. And then finally, there is the concept of similarity. So let's say there is a person A who is 170 centimeter height and is 60 kg in weight, and a person B has 172 centimeter height and 62 kg of weight. So if we calculate distance, it's going to be very small. I should write is very small between person A and person B. But if I compare it with another person which is 190 centimeters high and as 90 kg is his weight. So if we compare person A and person C, which will be uh, high distance or will be longer distance, the distance will be longer, right? So or the larger distance, right? So machine learning says that if a person A and B belong to one group, C belongs to a different group. So distance is equal to similarity measure. Distance is equal to similarity measure, right? So closer the points, similar will be the objects, and farther the points, different will be these objects. So here is a final example. This is exactly how machine learning and companies use machine learning. They put customers as points on a plane here, as you can see, and they create different clusters and then divide these group of people in different clusters. So cluster one, let's say this is these persons are the budget shoppers, and they may be the luxury spenders, and they may be like they do have a higher budget, but they are not spending much. Maybe they may belong to middle class families, right? So these groups are not guessed, they are really calculated as per their spending score. And this is all because of this group, all because of the distance. The distance between these cluster of people is very less, therefore they are into one cluster. They are in a second and third, and there are four clusters. So finally, let's quickly review what we learned. We learned what the Cartesian plan is. We saw how distance is calculated, and also take a look at took a look at explaining the distance formula and why it matters in the machine learning. Then we saw it the concept of similarity and clustering in machine learning, and saw an example of customers clustering example. So this was about the distance and distance formula and Cartesian plane. So math is a language of machines, and that's why we are studying it. I hope you have a good understanding about the Cartesian plane and distance.